So in this example, we're given expressions for time varying current, which is this expression here, and for time varying voltage. And so we're asked to use these and determine the charge in a device. So this would be the device here. So they want us to determine the charge in the device at t equals 2 seconds. And they're letting us know that at t equals 0, or when time is equal to 0, no charge is accumulated or traveled there. So let's see how we would approach this. So in part A, again, they're asking us to determine the charge. So we're given the current and the voltage. Well, we know in a time varying circuit that the current, we'll call I, of t is equal to the first derivative of the charge with respect to t. But we're wanting to find Q, the charge. So that being the case, we need to solve for Q. So to do that, we integrate both sides. So that would be dq is equal to I of t dt. And then if we integrate both sides, then that will give us what we're looking for. That'll give us Q. So in this case, then, Q is going to be equal the integral from 0 to t for I of, we'll say, tau, to switch variables, d tau. And then that's going to be plus our charge times 0, which they gave us. So in this case, if we plug the numbers in, it means we'll be integrating from 0 to 2, as they told us right here. So t equals 2 seconds. And then our expression for I of t, which we're going to get from right here. So that's going to be 20 times 1 minus e to the minus 2 tau dt, or d tau. And then we know this is 0, because that's what they told us right here. So that means plus 0. So if we perform this integral, so again, this is just back to basic calculus. What we come up with then is 20 times tau minus e to the minus 2 tau over, so minus 2, and then that will be evaluated from 0 to 2. So once we plug those numbers in the calculator, we should come up with 30.2 coulombs. So this is the answer to part A. So with that current definition from 0 to 2 seconds, the amount of charge that is delivered to the device, or in the device, is 30.2 coulombs. So now, part B, we're asked to determine the power supplied to the device at t equals 2 seconds. So we recall then that power is just equal to the voltage times the current. And so this is evaluated at t equal to 2. That's what we're given here. So that being the case, we can rewrite this then as our voltage. If we put in t equal to 2 right there, that 2 times 4 is 8. So then that will give us 10 times the sine of 8 times, and then in this equation, put in t, 2 for t there, we will get 20 times 1 minus e to the minus 4. Again, this is just a matter of plugging these values into a calculator and calculating them out. And when you do, you should come up with 194.3 watts. And so this is the answer to part B.